So, what if I told you the solid ground beneath your feet isn't solid at all? That it's actually moving right now? Well, today we're going to take a journey, a really deep one, from the super hot center of our planet all the way to the surface. We're going to uncover the colossal forces that build up mountains, set off volcanoes, and literally shift the world as we know it.
And that's a fantastic question, right? Because, the ground feels pretty solid, but the answer, it lies deep, deep underground. There's this powerful, restless engine just constantly at work down there, and its effects, well, they're anything but subtle. So to really get it, we've got to start at the very beginning, deep inside the Earth.
All right, Section 1, Earth's engine room. Yeah, to understand what's happening up here on the surface, we have to start our journey thousands of kilometers down, right at the very heart of our planet. Then, we'll work our way back out. Okay, so picture the Earth like a peach. We live on the crust, which is this incredibly thin skin. It's less than 1% of the Earth's entire volume. Beneath that, you've got the mantle. That's the thick, fleshy part, and it makes up the vast majority of our planet. And then right at the center, you have the pit. That's the super dense, super hot core made of nickel and iron.
Now, this is where it gets really fascinating. The core isn't just one thing, it's actually in two parts. You've got the outer core, which is this swirling sea of molten metal, and its movement is what generates Earth's protective magnetic field. Pretty cool, right? But then there's the inner core. And get this, even though it's hotter, it's a solid sphere. Why? Because it's being crushed into that state by just unimaginable pressure.
So you might be asking, where does all this incredible heat even come from? Well, it's what we call geothermal energy. It's partly heat that's been left over from when the planet first formed, but it's also being continuously generated by the decay of radioactive elements deep inside. You gotta remember, this internal heat, this is the fundamental power source for everything we're about to talk about.
All right, Section 2, a puzzle of plates. So you have all that internal heat, right? It has to go somewhere. It doesn't just sit there. It actively, and I mean actively, reshapes our planet's surface, turning it into this dynamic, shifting puzzle of giant plates.
So go back with me for a second. Over a century ago, there's this scientist, Alfred Wegener, and he proposes this totally radical idea. He suggests that all the continents we see today were once joined together, like one giant supercontinent. He even gave it a name, Pangaea. He believed they had just slowly drifted apart over millions of years to get to where they are now.
Now, Wegener was totally on the right track, but he was missing a huge piece of the puzzle, the how. How could this even happen? Well, the answer is the theory of plate tectonics. This theory tells us that Earth's rigid outer shell, the lithosphere, isn't one solid piece. Nope, it's broken up into these massive plates that are basically floating on a hotter, kind of gooey layer below it called the asthenosphere.
And look, this isn't just some wild guess. The evidence is just overwhelming. You can literally see how the coastlines of Africa and South America fit together like a jigsaw puzzle. And then scientists found identical fossils of land animals on continents that are now separated by vast oceans. How is that possible? But the real clincher, these magnetic zebra stripes on the ocean floor. They act like a geological tape recorder, proving that new crust is constantly forming and pushing the continents apart. Just incredible stuff.
So what's the engine driving this epic continental-scale movement? It's that geothermal heat we talked about. It creates these massive convection currents in the mantle. The best way to think about it is like a giant pot of boiling soup. Hot stuff from the bottom rises, spreads out across the top, cools down, and then sinks again. And this slow, super powerful circulation is what drags the continental plates along for the ride.
Okay, Section 3, where worlds collide. So what happens when these massive, continent-sized plates actually run into each other? Well, that's where we get some of the most dramatic, most powerful geological events on the entire planet.
And these interactions basically happen in three main ways. At what we call divergent boundaries, plates are pulling apart from each other, creating new crust. Then you have convergent boundaries, where they're pushing together, smashing into each other, building mountains, or carving out those super deep ocean trenches. And finally, you've got transform boundaries, where they just slide and grind past each other, building up an insane amount of stress. Get ready for this number, a truly staggering 75%. That's 3/4 of the world's active volcanoes are located along what's called the Ring of Fire. And this is no accident. It's a massive chain of these convergent boundaries all around the Pacific Ocean, where oceanic plates are constantly being forced down or subducted beneath continental plates.
But this brings up a really cool question.
If convergent boundaries create volcanoes, then why are there none in the Himalayas, the tallest mountain range in the world? Well, the answer is that the Himalayas were formed when two continental plates collided. See, neither plate was dense enough to sink under the other one. So instead of one going down, they just crumpled upwards, creating these massive mountains, but without any of the melting rock you need to get volcanoes.
All right, section 4, the planet shakes. Now, all this grinding and crashing and pulling apart, it doesn't happen quietly. And one of the most sudden and, frankly, terrifying consequences of all this plate movement is the earthquake.
You know, an earthquake isn't just random shaking. It's a process. Think of it like this. As plates grind against each other, they get locked up, and stress just builds and builds along a fault line for years, sometimes even centuries. The rock is literally bending. Eventually, that stress becomes too much, the rock snaps, and boom, all that stored up energy is released in an instant as seismic waves.
And these waves are actually how we've learned so much about what's inside the Earth without ever drilling down there. There are two main types you need to know about. P waves, or primary waves, which are super fast and can travel through both solids and liquids. And then there are S waves, or secondary waves. They're slower, but here's the crucial part. They can only travel through solids. This one little difference, well, it changes everything.
Because S waves can't pass through liquid, scientists noticed something absolutely incredible. After a major earthquake, there's this huge shadow zone on the complete opposite side of the planet where no S waves are ever detected. They just disappear. This shadow was the smoking gun. It was the definitive proof that confirmed Earth's outer core is a massive sphere of molten liquid. Okay, last section here. Section 5, sculpting the surface. So we've talked about these powerful forces building things up from inside the Earth. But believe it or not, that's only half the story. Up here on the surface, there's a constant battle of forces that shapes the world we actually see and live on every single day.
Our planet's surface is basically locked in a constant tug of war. On one side, you have endogenic forces. These are the internal ones, powered by the Earth's heat. They build things up, creating mountains and volcanoes. But on the other side, you have exogenic forces, powered by the sun, and their job is to tear everything down through weathering and erosion. And these external forces have a whole toolbox they use. First, you've got weathering. That's wind, rain, and ice just breaking rocks down into smaller pieces. Then comes erosion, where things like rivers, glaciers, and wind carry all those pieces away. And finally, there's deposition, where all that material gets dropped somewhere new, creating things like sandy beaches and fertile river deltas. It's just this relentless cycle of destruction and creation, happening all the time.
And that really leaves us with a final mind-bending thought. The ground beneath us isn't static. It's not permanent. It's a living story of creation and destruction, all driven by a hot, rustless core, and then sculpted by the sun from above. The world map that we all know so well, that's just a snapshot in geological time. The very same forces that created it are still at work right now, constantly writing the next chapter of our planet's incredible story.